A standard ceiling fan pre-wire should include a 3-gang electrical box, 14/3 cable with a neutral wire, hot wire, and ground wire for the fan, and 14/2 cable with a neutral wire and hot wire for a switched receptacle. In some cases, builders may opt to use a 2-gang box when certain conditions are met. These conditions include when the ceiling fan is controlled by a single switch, and the light is either on a separate switch or not controlled at all, requiring only a 14/2 cable for the fan, and when the switched receptacle is not on the same circuit as the ceiling fan and requires its own 14/2 cable. Using a 2-gang box for a ceiling fan pre-wire that requires a 14/3 cable has several consequences, one of which is a crowded electrical box. The wires from the 14/3 and 14/2 cables will be cramped within the small space of the box, making it difficult to work with. Another consequence is a potential code violation. The National Electrical Code, specifically the 2014 edition, requires that electrical boxes have sufficient space for the number of wires present. A 2-gang box is typically too small for a 14/3 cable and a 14/2 cable. The best solution is to install a 3-gang electrical box when pre-wiring for a ceiling fan. This provides ample space for all the necessary wires and ensures that the installation meets code requirements. A double switch, fan or light control can be used as a workaround when a 2-gang box is already installed. However, this solution is not ideal as it limits the homeowner's ability to control the fan and light separately. According to the NEC, specifically the 2014 edition, the number of conductors permitted in a box is outlined in tables 314.16 and 314.16b. These tables take into account the volume of the box and the size of the conductors. It is essential to ensure that the box is large enough to accommodate all conductors, including those for the fan, light, and receptacle circuits, along with any grounding conductors and equipment grounding conductors as well. When dealing with a pre-wired ceiling fan installation, several factors must be considered to ensure compliance with the NEC. Firstly, the box fill calculation, as per NEC 314.16, must be accurately performed. This calculation determines the minimum size of the electrical box required based on the number and size of conductors, device yokes, and equipment grounding conductors present in the box. Secondly, the wiring method employed must adhere to NEC standards, including the use of appropriate cable types, such as 14/3 and 14/2, and proper installation techniques. Additionally, the grounding and bonding of the electrical system must be in accordance with NEC 250 to ensure electrical safety. Lastly, any modifications or alterations to the existing electrical system must comply with NEC 110.3b, which requires that all equipment be installed and used in accordance with its listing and labeling. Let's delve deeper into the specific code requirements that govern the installation of electrical boxes and wiring for ceiling fans and switched receptacles. Firstly, NEC 314.16, as previously mentioned, dictates the rules for box fill calculations. This section provides detailed guidelines on how to determine the minimum size of an electrical box based on the number and size of conductors, device yokes, and equipment grounding conductors present within the box. It is essential to accurately calculate the box fill to ensure that the box is not overcrowded, which can lead to overheating and potential safety hazards. Secondly, NEC 314.17 outlines the requirements for conductor entry into boxes, conduit bodies, or fittings. This section specifies the methods and techniques for properly securing conductors as they enter the box to prevent strain on the connections and ensure reliable electrical connection. Additionally, NEC 314.27 addresses the specific requirements for outlet boxes used for ceiling suspended, paddle fans, and luminaires. This section mandates that boxes used for supporting ceiling fans must be listed and marked as suitable for this purpose, and they must be capable of supporting the weight of the fan without causing any structural damage. Furthermore, NEC 404.2 provides guidelines for the installation of snap switches, including those used to control ceiling fans and switched receptacles. This section specifies the mounting height, accessibility, and wiring requirements for switches to ensure safer and convenient operation. It is imperative to adhere to these code requirements to guarantee the safety and functionality of the electrical installation. The use of a 2-gang box instead of a 3-gang box can lead to several issues beyond overcrowding and code violations. Firstly, it can create difficulties during installation and maintenance. The limited space within the box makes it challenging to manipulate the wires, tighten the connections, and properly position the devices. This can result in a time-consuming and frustrating installation process, as well as increased difficulty in troubleshooting and repairing any future problems. Secondly, a crowded box can increase the risk of loose connections. When the wires are tightly packed together, they may not be able to make solid contact with the terminals of the devices, leading to loose connections that can cause flickering lights, intermittent power outages, and even electrical fires. Thirdly, a 2-gang box may not provide adequate space for heat dissipation. Electrical components such as switches and receptacles generate heat during normal operation. If the box is too small, the heat can build up, potentially damaging the devices and reducing their lifespan. In contrast, a 3-gang box offers several advantages. Firstly, it provides ample space for all the necessary wires and devices, making installation and maintenance easier. Secondly, it reduces the risk of overcrowding, loose connections, and heat buildup, enhancing the safety and reliability of the electrical system. Thirdly, it allows for greater flexibility in wiring configurations and future upgrades, accommodating additional switches, dimmers, or other control devices as needed. In summary, when pre-wiring for a ceiling fan and switched receptacle, it is generally recommended to use a 3-gang box to ensure compliance with the NEC, facilitate installation and maintenance, and enhance the safety and reliability of the electrical system. While a 2-gang box may be acceptable in certain limited situations, it is essential to carefully evaluate the specific requirements of the installation and consider the potential consequences of using a smaller box. When performing electrical work, it is crucial to prioritize safety and adhere to all applicable codes and regulations. Always consult with a qualified electrician if you have any questions or concerns about the proper wiring methods and box fill calculations for your specific installation. It's also very important to consider the long-term implications of choosing a smaller electrical box. While it may seem like a minor detail, the decision can have a significant impact on the functionality and flexibility of the electrical system over time. For example, if the homeowner later decides to add a dimmer switch or smart control device to the ceiling fan, a 2-gang box may not have enough space to accommodate the additional wiring and components. This could require replacing the entire box, which can be a costly and time-consuming undertaking. Furthermore, a 2-gang box may limit the homeowner's options for future upgrades or modifications to the electrical system. As technology advances and new devices become available, the homeowner may want to install additional outlets, switches, or control systems. A larger 3-gang box provides more flexibility to accommodate these future needs without requiring extensive rewiring or box replacements. In addition to the practical considerations, there are also aesthetic factors to consider. A 3-gang box provides a cleaner and more professional look compared to a crowded 2-gang box. The extra space allows for neater wiring and more uniform placement of the devices, enhancing the overall appearance of the installation. From a safety perspective, it's worth noting that overcrowded electrical boxes can increase the risk of electrical fires. When the wires are tightly packed together, they can generate excessive heat, which can damage the insulation and potentially ignite combustible materials in the vicinity. A larger 3-gang box provides better ventilation and reduces the risk of heat buildup, minimizing the potential for fires. Moreover, it's important to consider the potential liability associated with using a 2-gang box when a 3-gang box is recommended. If an electrical fire or other safety hazard occurs due to an overcrowded box, the installer or builder could be held liable for damages and injuries. Using a 3-gang box demonstrates a commitment to safety and reduces the risk of liability in the event of an incident. In summary, While a 2-GaN box may seem like a convenient and cost-effective solution in certain situations, it's crucial to weigh the potential consequences against the benefits. A 3-GaN box provides ample space, enhances safety, offers greater flexibility, and improves the overall appearance of the installation. When pre-wiring for a ceiling fan and switched receptacle, it's generally recommended to opt for the larger box to ensure compliance with codes, facilitate future upgrades, and minimize the risk of electrical hazards. Furthermore, it's important to consider the specific requirements of the ceiling fan and switched receptacle when determining the appropriate box size. Some ceiling fans may require additional wiring or control devices such as remote receivers or speed controllers, which can increase the amount of space needed in the electrical box. Similarly, some switched receptacles may be part of a larger lighting control system or have additional features, such as surge protection or USB charging ports, which can also impact the box fill calculation. Before installing any electrical wiring or devices, it's essential to consult the manufacturer's instructions and specifications to ensure that they are compatible with the electrical box and wiring system. Additionally, it's always a good idea to consult with a qualified electrician to ensure that the installation meets all applicable codes and safety standards. In addition to the number of conductors and devices in the box, it's also important to consider the type of wiring used. Non-metallic sheath cable, such as 14/2 and 14/3, is commonly used for residential wiring. However, the size and type of cable can affect the box fill calculation. For example, larger gauge wires, such as 12 gauge or 10 gauge, require more space in the box than smaller gauge wires, such as 14 gauge. Similarly, cables with thicker insulation or sheathing can also take up more space. When performing a box fill calculation, it's important to consult the NEC tables to determine the appropriate volume allowance for each type and size of conductor and cable. The NEC tables provide specific guidelines for calculating the box fill based on the wire gauge, insulation type, and the presence of any internal cable clamps or fittings. To further illustrate the importance of proper box fill calculations, let's consider a specific example. Suppose you have a 2-GaN box that measures 3 inches by 4 inches by 2.5 inches deep. According to NEC Table 314.16a, this box has a volume allowance of 20 cubic inches. Now, let's say you need to install two 14/3 cables, one 14/2 cable, and 2 switches in the box. According to NEC Table 314.16b, each 14-gauge conductor requires a volume allowance of 2 cubic inches, and each switch requires a volume allowance of 4 cubic inches. Based on these values, the total volume required for the conductors and devices is 26 cubic inches, which exceeds the box's 20 cubic inch volume allowance. In this scenario, using the 2-GaN box would violate the NEC and could create a safety hazard. The proper solution would be to install a larger 3-GaN box with a sufficient volume allowance to accommodate all the conductors and devices. In addition to the box fill calculation, it's also important to consider the working space around the electrical box. The NEC requires that there be adequate working space around electrical equipment to allow for safe and convenient access for installation, maintenance, and repairs. The working space requirements vary depending on the voltage of the electrical system and the location of the equipment. However, in general, there should be at least 3 feet of clear space in front of the electrical box, with a minimum width of 30 inches and a minimum headroom of 6 feet 6 inches. The working space should be free of obstructions such as furniture, equipment, or storage items that could impede access to the electrical box. Furthermore, the working space should be adequately illuminated to allow for safe and accurate work. Insufficient working space can make it difficult to install and maintain electrical equipment, increasing the risk of electrical shock or other injuries. The NEC also includes specific requirements for the labeling and identification of electrical boxes and wiring. All electrical boxes must be clearly labeled with the voltage and amperage of the circuits they serve, as well as the date of installation. The wiring within the box must also be properly identified, using color-coded wires or labels to indicate the purpose of each conductor. Proper labeling and identification can help prevent confusion and errors during installation and maintenance, reducing the risk of electrical hazards. In addition to the NEC requirements, there may also be local codes and regulations that govern the installation of electrical boxes and wiring. It's important to check with your local building department to determine if there are any additional requirements or restrictions that apply to your specific location. Local codes may vary depending on the climate, terrain, and other environmental factors. They may also include specific requirements for the type of materials used, the installation methods employed, and the inspection procedures followed. In some cases, local codes may be more stringent than the NEC requirements, so it's important to be aware of any local variations. Finally, it's worth noting that electrical codes and standards are constantly evolving to reflect advancements in technology and changes in safety practices. The NEC is updated every 3 years, and new editions are released to address emerging issues and improve the safety and reliability of electrical systems. It's important to stay up to date on the latest code requirements and to consult with a qualified electrician or electrical inspector if you have any questions or concerns about compliance. By following the proper procedures and adhering to all applicable codes and regulations, you can help ensure the safety and reliability of your electrical system and protect yourself and your property from electrical hazards. In conclusion, when pre-wiring for a ceiling fan and switch receptacle, it's generally recommended to use a 3-gang box to provide ample space, enhance safety, offer greater flexibility, and improve the overall appearance of the installation. While a 2-gang box may be acceptable in certain limited situations, it's crucial to carefully evaluate the specific requirements of the installation and consider the potential consequences of using a smaller box. Always consult with a qualified electrician or electrical inspector if you have any questions or concerns about the proper wiring methods and box fill calculations for your specific installation.